Hello everyone, I'd like to welcome you to this video titled Ratios, Rates, Tables, and Graphs. And for this video, I want you to get out your math book and turn to page 173. Get out your math journal and a pencil. You also need a calculator for this as well. Now the goal for this video, what we're going to be doing is we're going to be making tables of equivalent ratios. We're going to take a look at finding the missing values in the tables. As you can see on this table right here, there's some missing values, so we're going to see how to figure out what those missing values are, and then we're also going to plot the pairs of values on the coordinate plane. And we have done all these different things throughout this year, but we're going to put it kind of all together here in this video. So let's take a look at page 137 and the problem on page 137. As you can see, that may look like somebody you know when they wake up in the morning. Hopefully it's not you, but we can see that students in Mr. Webster's science class are doing an experiment that requires 250 milliliters of distilled water for every 5 milliliters of ammonia. So we can see that's the ratio there, 250 to 5. The table shows the amount of distilled water needed for various amounts of ammonia. So we can see that ratio is right over here, 5 to 250, 5 ammonia milliliters and 250 milliliters of distilled water. Now, what we're going to do, we're going to use the numbers in the first column of the table to write a ratio of distilled water to ammonia. Okay, so remember it's distilled water to ammonia, so it's going to be 100 to 2. So that's the ratio that we see right there. Even though ammonia is on top, distilled water is on the bottom, they're asking us to write a ratio of distilled water to ammonia. Now the next question is asking us how much distilled water is used for 1 milliliter of ammonia. Now that's not on here on our table at all, but if we know that 100 milliliters of distilled water is used for 2 milliliters of ammonia, what we can do here, so 100 to 2, that's going to equal to something over 1. Now we just need to think about what do we do to 2 in order to get it to 1. We divide by 2. And remember, whenever you're finding equivalent ratios, you have to divide both by the same number. So 100 divided by 2 is 50. So that gives us the unit rate, 50 to 1. So when we find the unit rate, that can help us as we start to fill in some of these other missing areas of our table. Now it says, use your answer to write another ratio of distilled water to ammonia. Okay. And then what we can do is just take that ratio of 50 to 1 and write it right here for letter B. And I would like you to do that with me as well. Now let's jump down to the next part. It says the ratios in A and B, what are they? Equivalent or not equivalent? So we can see A is 100 to 2, B is 50 to 1. We can see that they are equivalent. Why do we know that they are equivalent? And we'll circle that for letter C. Because we took 100 to 2 ratio, we divided it by the same number. Okay, both terms by the same number, 50 to 1 for that ratio. Now it's asking us for letter D. How can your answer to B to find the amount of distilled water to add to a given amount of ammonia? Okay, so how can we use this answer here to fill in the rest of the table? And we can use that answer by multiplying the amount of ammonia by 50. Okay, so we can see 2 times 50 gives us 100. 3 times 50, we can see there is going to give us 150. 3.5 times 50 is going to give us 175. Now we need to think about if we're multiplying this number by 50 in order to get to this distilled water, if we don't know what the ammonia is, but we know the distilled water, we just do the inverse operation. So for this, we can take 200. Instead of multiplying that by 50, we're going to divide it by 50. Okay, so that's going to give us 4 for that one. So now based upon this, we can complete letter E. Okay, so we see the table with the equivalent ratios, We have 150 here. Then we write in 175 based upon our table right above, 200 to 4, and then we have all of those are equal to 250 to 5 for our ratio. That was shown in the story problem above. Now let's take a look at page 174. I'd like you to turn there. Now what we're going to look at, we looked at already finding ratios from tables, so now we're going to look at graphing with ratios. Okay, so what we need to do first of all is copy the information from 173 from that table that we already filled out. We'll do this together. So now that we have that information, we take a look at letter B, and remember this is graphing with the ratios that we have. It says write the information in the table as ordered pairs. Use the amount of ammonia as the x coordinates and the amount of distilled water as the y coordinates. So we can see distilled water here, ammonia here. So if we have the ratio of 2 to 100, write the ordered pair 2 to 100. 3 to 150, 3 to 150. 3.5 to 175, our ratio, we'll write it like that, and then also 4 to 200. Now the next thing that we're going to do is we're going to graph these ordered pairs. Okay, so this is just showing the data in our table, and we're going to graph it now. So we have 2 to 100, so we go over 2, plot our point at 100. 3 to 150, so we go 3 here, and then we have 150 there. 4 to 175. Plot our point right at 175, kind of between the 150 and the 200. And then we already have our point of 5 to 250 already plotted there. Now that we have this plotted, what we're going to do is just connect these dots. I'm going to do it with a red pen, just so you'll be able to see it a little bit easier. So start at the 0. I'm going to connect these dots. Try as best as you can to make a straight line. Now the next thing we will look at is just describing our graph. Okay, so I know this is not the straightest line that you'll ever see, but we can see that the line, the graph is a line. Okay, so we'll write a line here. That just shows us that our ratios are all equivalent. If it was just something that looked like the Mississippi River, we would know that the ratios are not equivalent. But the fact that when we connect our dots, it creates a line that shows us that they are equivalent ratios. Now the next question they're asking us is for each ordered pair that you graphed, write the ratio of the y coordinate to the x coordinate. So we're going to take a look at the y to the x. So if we have 100 to 2, and then we have 150 to 3, 175 to 3.5, the ratio is 50. I'm sorry, the unit rate is 50 to 1, but we can see the ratios here for C would be 100 to 2, and then 150 to 3, 175 to 3.5. We'll write these down with me. 200 to 4, and 250 to 5. So those are all the ratios that are represented on my graph. So we can see the ratio of distilled water to ammonia for this, 50 to 1. How are the ratios in C related to this ratio? Okay, so we can see that they are all equivalent. And how do we know that they're all equivalent? If you take 50 to 1 next to any of these, okay, you can multiply both terms by the same number and you would get any of these ratios. So if we took 50 to 1 and compared it to 200 to 4, We can multiply the 50 by 4 gives us 200. The 1 times 4 gives us 4. So that would mean it would be an equivalent ratio. Now let's jump down to letter E. It says the point 2.5 to 125 is on the graph, but not in the table. The ratio of the y coordinate to the x coordinate would be what? So let's take a look at this. Y coordinate to x coordinate. We can see 125 to 2.5 would be the ratio. I don't have the room to write it there, so I'm just going to write it off to the side. 125 to 2.5. How is the ratio related to the ratios in C and D? So let's take a look at it. C and D. Take a look at our unit rate first of all. 50 to 1. So we take 50 to 1, we're going to compare it to 125 to 2.5. So let's figure out, what do we have to multiply 1 by to get to 2.5? Multiply it by 2.5. What that would do, that would give us 2.5. And then what we would have to do is we would have to multiply the 50 by 2.5 as well. And that would give us 125. So because we multiply both terms by the same number, and we get that 125 to 2.5 ratio, that would mean it's equivalent. So we'll write, they are equivalent. So we can see 2.5 milliliters of ammonia requires 125 milliliters of distilled water. So the question that we can see here at the bottom, why do you think this is true for every, what do you think is true for every point on the graph? So we see that the y coordinate is the correct amount of water for the amount of ammonia given by the x coordinate, which would be the unit rate of 50 to 1. So let's turn our books to page 175. What we're going to do is we're going to take these two skills of completing a table with missing blanks and also graphing our information all into one problem. So we can see for question 3, it says a shower uses 12 gallons of water in 3 minutes. So that's our rate that they're giving us. And it's saying complete the table and graph. Now, what we can see is 12 gallons of water in 3 minutes. So we take a look at our table here. All right, and we think about this right here, 3 minutes. So that's going to give us 12 gallons in 3 minutes. So in order to fill the rest of the table in, we need to think about what is happening to our 3 in order to get it to 12. What we're doing is we are multiplying that 3 by 4 in order to get it to 12. Okay, now if we want to break it down even further, we can take a look at this unit rate. So we can see that there are 4 gallons of water for every minute. Okay, so that would be another way of doing that. Okay, so we have 4 to 1. Taking a look at our table, we can even switch it up with 1 gallon. 4 gallons for every minute. Okay, and then you can fill the table in that way. That would be another way of doing that. All right, so if we know that if we multiply 3 times 4, that's going to give you 12. What do you do to 2? What do you get when you multiply 2 times 4, and that's going to give you 8. Now when we think about 3.5 times 4, that's going to give us 14. Now if you remember from the other one, since we do not have this top number, we just have the amount of gallons that are being used. Instead of multiplying that 20 by 4, we're going to take that 20, we're going to divide it by 4. And we know that's going to give us 5 minutes there, because 20 divided by 4 is going to give us 5. Again, 6.5 times 4, that's going to give us 26 now. So now it's time to graph our data right into the table here. We need to understand that the time represents the x-axis. The water used in gallons is going to represent the y-axis. So the first section here, first set of data, is the order pair of 0.28, and then we have an order pair of 312, and then we have 0.314, then we have 0.520, and then we have 0.6 and a half and 26. So now from here we're going to graph our numbers on our coordinate grid, and what we see here is 2 and 8, so we go over 2 and then go up 8. 3 and 12, we go over to 3 and we go up 12. Now we can see these are intervals of 4, 8, 12, so we have intervals of 4 here. So we're going to go to the 3. Whoops, I did not mean to plot that there. We have 12 there. Let me erase that. Now the next one, we have 3.5, so we're going to go over 3.5, and then we're going to go up 14, which is going to kind of be in between the 12 and 16 there. Do the best you can with that one. 5 and 20, so I go over 5 and I go up 20 here. And again, if you have equivalent ratios, this is going to be a straight line. And then now we're going to go to 6.5, and then 26, which is going to go right between the 24 and 28. We'll plot our point just about right there. Now the final thing we are going to do is take our start at 0 there, start the origin, and we're going to connect our dots with that straight line. And again, if it is a straight, they are equivalent ratios, it's going to be a straight line, as straight as I can get when I'm writing here digitally. And that kind of shows you how we go from missing numbers on a table and then taking that table and then graphing it there on a coordinate plane. So this concludes the video on ratios, rates, tables, and graphs. If you have any questions about this concept, please come and see me.